All right, we're back. We're on page 201. We just answered part B. There are some birds going insane outside. I don't know if you're picking that up. I am still in my work. I just wanted to highlight something. And like in the last video, I said, I hope I remember it. I stored this as TD min, time for distance minimum, because I think there's a question later that involves like at the minimum time. So let's go back and see what the next question is. So I'm assuming you're just like watching these all the way through or just jumping in where it like makes sense to you. So I'm gonna assume that you're up to date on what we've been doing and carry on. So times being what they are, participants actually use a laser gun to shoot the targets. This means there's no real projectile. Instead, a computer decides if a projectile would have hit the target. As a result of this, a really skilled sharpshooter can actually hit both targets at once. Okay, suppose a sharpshooter wants to hit both targets, obviously. Is this possible if she shoots at t equals 3 seconds? Where would she need to position her ray gun? So where does she need to be so that she can hit both targets at t equals 3? Where does she need to be? Well, I think there's more than one option for that, but how on earth? Okay, so let's go to GeoGebra. And I'm trying to like think how I'm gonna do this, how I would ever do this. All right, well, so she's gonna shoot and she wants to hit both targets. So let me just move the slider here. And she wants to hit them at t equals 3. So I mean, if I just put the slider at t equals 3, come on, can I even do it? Here, I think it's going by 0.5s. So 1, 2, 3. Okay. This is the positions at t equals 3. These are the positions. This is a whatever. So she needs to hit both of them. So she just needs to be on the line that's connecting them, right? So how do you make a line? Can I just do line? Line, point, point. So what are the names of the points? F and C. Okay. If she's standing on this line and she shoots at t equals 3, she will definitely hit both of them. So yes, there's definitely a spot. Actually, there's two. She could either be here or she could be here. How are we gonna find those? Like, I know that I can find them on here without a problem. I wanna be able to find them though, using, I guess maybe the calculator. So let's go back to the notes and like think this through. So I need to find, actually, I probably should have stayed on there for a second, but whatever. Okay, so there's a time, and what she's gonna do is she's gonna shoot, let's say, you know, like this. All right, so what I need to do is I need to find this and this. So what I really need is I need to know the equation of this line, and then I'll just intersect it with this, all on the calculator, not doing that by hand. And that'll be it. So how do I find the slope though? Well, this is where target 2 is, and this is where target 1 is. So if I do the equation of target, like x1, y1 of 3, this is x2, y2 of 3. Okay, so this point right here is gonna be x1, y1, x1 of 3, y1 of 3. I'm gonna use the calculator, like I'm typing that in. I'm not gonna actually find the point. And this is x2 of 3, y2 of 3. So we can write the equation that line, I think, and then intersect it. Sure we can. So we're on another page, it turns out. So part C. Okay, the plan, intersect line through T1 and T2 at t equals 3 with x squared plus y squared equals 400. That's my plan. So let's write the equation of that line like super weirdly generally. The line at t equals 3. I'm gonna use point slope and say it's like y minus y1 of 3 equals, so I'm just like, I'm going for it. It's gonna be the change in y, so y2 of 3 minus y1 of 3 over x2 of 3 minus x1 of 3. So this is weird. Maybe you've never done this before. The calculator's going to be cool with it. So for point slope, I have to do x minus the x coordinate that goes with this, right, which is x1 of 3. Holy cow. All right. So we're going to intersect that with x squared plus y squared equals 400. It's going to give us 2 points, and those points are where she could be standing, I think. So to the calculator, and we're going to make it happen. And then I don't know how I'm going to interweave GeoGebra with this, but we'll find a way. So I'm going to put in a new calculator page because there's just a lot going on. Still on the same problem though, because I want to be able to get all of these. So, all right, let's just solve. Let's never know. Menu 3.7. Let's never know what the actual thing looked like. So what are we solving for? X and Y, I guess. 2 equations, 2 unknowns. X and Y are the unknowns. So I'm going to say y minus, I'm typing it in, y1 of 3 equals y2 of 3 minus y1 of 3 over x2 of 3 minus x1 of 3, quantity, x minus x1 of 3. That, I think, is the equation of the line. Like, I think that's going to do it. And then x squared plus y squared equals 400. And then we're solving for x and y. I'm going to hit enter and see if I get exact values. Oh, I'm going to not do that. I'm going to hit control enter and get decimals. So negative 15 and God, are these on, like, squaring things is so weird. Like it feels like 15 squared and 13 squared should be way more, but it's like 225 and 169. Like it's definitely not way more than 400. So what should I write down here? I'm gonna write down those ordered pairs. So negative 15.1019 comma negative 13.1124. And then the other one is 17.8404. Like, could I get an exact value for these? I think I could. I think I don't want to, but I think I could. 999. Okay. So I got them written down. I'm gonna go back to the note. Well, should I just go back to the notes? You know what I was thinking of doing was I'm gonna copy this. I'm gonna store this as a function. So I need to move this. It's actually this, right? Because I gotta like move the thing over and store this as f1 of x. Okay, there's something in f1, so I'm gonna make it f2. So this is the line. And then let me add another graph page. Just like see if I'm right. So I'm gonna turn this on, okay. And then what else am I doing? Oh, I was gonna put like, so square root of 400 minus x squared. So that like the top half of the circle, and just find the intersection. Menu 6, well menu, I prefer menu 814 intersection points. I don't really know why. Yeah, that's the point we got. So this appears to have worked. And then I'm gonna do negative square root of 400 minus x squared for the bottom half of the circle. To menu 814, quick, negative 50. Yeah, okay. So another thing that I could potentially do at this point is I could add in the parametrics and just like see if it worked. I think what I'm gonna do though, first of all, I think we got this. So let me switch back to the notes and like write up my answer. So it's like a couple of little things here. So the system, right? Solve the system. And then I'm gonna duplicate this, kind of like cheating, but you know, duplicate that, and then also x squared plus y squared equals 400. It did all the work for us. These are the intersection points. So if she stands at negative 15.102 comma negative 13.112 or 17.840 comma 9.040, I guess, she will hit both targets at t equals 3. Good for her. I'm going to go to GeoGebra and just, because I think GeoGebra can do this for us without a problem. I don't really know. Do I think that? I mean, I think that. But right now, this point, let's find the intersection points. So intersect this with this. And you can see it gives us those. And this is happening at t equals 3, right? At the time is 3 up here. So I think that's confirmation. If we stand at this point, we go through those 2 points. If we stand at this point, we go through those 2 points. I think that that's all the confirmation that we needed. So, all right, back to the notes. We're done with this one. I'm going to stop this here because who knows? I don't know how long this video is. So I think we answered part C. What do we have coming up? D, E, F, and then G we're doing as we go. So that's good. But we answered this. At t equals 3, we now know where she should stand. All right, I'm going to end this. I will be back in the next one to tackle part D. All right, see you there.